Alright, you have a worksheet in your week 3 packet which is on graphing polynomial functions without a calculator and getting a decent sketch of those graphs. So to be able to do that, you need to be able to identify and apply certain characteristics of the equations of the functions that you see. And it's really 4 of them, and all but one you already know about. The first thing you need to be able to identify is the degree of the function, which you all know is just the highest power. And then you also need the leading coefficient. Which is the coefficient that goes with the same term that has the degree. So for example, if you have, let's say it's not even in standard form and it's out of order a little bit. Okay, you have a polynomial like this. The degree would be 3 and the leading coefficient would be 5 because that's the coefficient that's in there with the degree. If this was in standard form in order, this would be first. So you need degree, you need leading coefficient, you need your zeros or x-intercepts or roots, which you'll be able to find when you have this in factored form. And then the last piece that you haven't probably learned about yet is something called multiplicity, which just means if you have the same zero repeated more than once. So that would be, you would have, usually, most of the time you're going to have a multiplicity of 1 because it won't be repeated, but what you might see sometimes is you might factor something and maybe it comes out to be x plus 3, x plus 3. Then if you set those equal to 0 and solve for x, you'll get x equals negative 3 twice. So that means that negative 3 would have a multiplicity of 2. Usually your multiplicity is 1 because usually it's not repeated, but sometimes you have that same factor twice and then you would have a multiplicity of 2, or imagine you could potentially have it 3 times and then you'd have a multiplicity of 3. Alright, so those are the 4 things you need to be able to identify. Then based on your degree and leading coefficient, that'll have an effect on what your graph looks like. So for your degree can either be even or it can be odd. And if you observe the differences between the graph of x squared, which you know is a parabola, and if you think of the graph of, well, x cubed, if you graph x cubed in your calculator, if you haven't seen it before, it pretty much looks like something like this. So really what we want to pay attention to here is something called the end behavior, which we'll learn more about later, but it's really just what are the ends doing here. So if you have an even degree function like x squared, both of your ends are pointing up. If you have an odd degree like x to the third, it's going down on the left and up on the right, because you always have your left end and your right end. Even degree, they're both going up. So for even, I'm going to make it like this, even though if you have the 4th power, 6th power, whatever, there might be some squiggles in the middle. That doesn't matter, we're just looking at the ends for now. Odd degree is going to be like this one, where one end is down, one end is up. And again, there could be squiggles in the middle, but we're focusing on the ends, because that's going to help us know where to start and end our graph. Then as far as our leading coefficient, really the thing to notice there is whether it's a positive number or a negative number. And if it's a negative number, like we've learned with transformations, if you have a negative leading coefficient, then this graph is going to be flipped upside down. So if you have even, instead of these both pointing up, they're both going to be pointing down. And if you have odd, instead of going from down to up, it's going to be reflected, so it's going to be going from up to down. So that's the information you get from degree and leading coefficient. And then if you have some repeated zeros, then you have to take your multiplicity into account. So basically, if you have an even multiplicity, like in that example where you had x equals negative 3 twice, negative 3 was a 0 with even multiplicity, then at your 0, which in this case would be at -3, don't cross x-axis. If it has an odd multiplicity, you do cross the x-axis. Because remember, your zeros are the same thing as your x-intercepts. So most of the time you would expect, if you have an x-intercept somewhere, you would expect that you're crossing. But sometimes maybe you'll have your x-intercept and maybe you'll just touch it and come back up. So if you have an even multiplicity, it would be more like this. If you have an odd, it'll cross. So we're going to see an example where we put this all together. It's kind of a lot of information, but we'll see what this looks like now. So graph f of x equals x times 2x minus 3 times x plus 2. Now keep in mind, on your sheet, I don't think they're factored right away. So for the ones they give you, you're going to have to factor them first, but hopefully you remember all the skills you need to be able to do that factoring. This one we're just skipping to the next part, which is we're going to identify our important information here. So if we look at our degree, we can see if, before this was all factored up, right now we've got 3 different linear factors with 1, 1, and 1. When they're all multiplied together, it's going to give you 3. You'll see it when it's in expanded form given to you too. It'll be really easy to see. But your degree is 3. 3 linear factors. If it's in expanded form, standard form, it's going to have an x to the 3rd. Then your leading coefficient, if you like multiply these x terms all together, you're going to end up with 2x to the 3rd, so your leading coefficient is going to be 2. But it's really enough to see that they're all positive and your leading coefficient is going to be positive. It's important to see your leading coefficient is positive and your degree is odd. So that means that if we look back up here, this is the area we're going to be in. Positive leading coefficient, odd degree. We're going to be going down on the left and up on the right. So we'll keep that in the back of our mind. Then the next thing we're going to do, though, is mark our zeros. So if these are our 3 factors, we would break them up and set each of those factors equal to 0. So x equals 0, 2x minus 3 equals 0, x plus 2 equals 0. And we solve those out real quick. And so, well, this one's already solved. And then on this one, we would do plus 3 divide by 2. I'm just going to skip ahead. X is 3/2. And then on this one, subtract 2, you get x equals -2. So since those are your zeros, you can go ahead and mark those points on your x-axis because those are, of course, your x-intercepts. So you can go over, okay, -2, there's 1. 3/2 is right here, 1.5. And then, oh yeah, there's 0. So you got your zeros. And then you need to check your multiplicities because that tells you whether it'll cross or not. As we can see, none of these are repeated. We didn't have x plus 2 to have that be repeated. So these all just have multiplicity of 1. Which means that's just default, they're going to cross. We're not going to have anything coming up and touching and going back. It's going to cross. So we'll keep that in mind. Then we go back to this end behavior here. Odd leading coefficient. So on the left it's going down, so that means it has to pass through this point right here. But to the left of here it's going down. We don't know how steep it is or whatever. This doesn't have to be that perfect. That's all we need to know is it's going down. Then on the right, when we get past this 0, it's going up. So we know it's going up from here. And then once we have that down, the multiplicities tell us everything else we need to know. So we know we're crossing, so instead of we don't want to bump back down here, we want to cross to the other side. And then make it back down here so we can cross, and then make it up here. Is this the most perfect graph? Do we know the y coordinate of this point? No, but this is good enough for our purposes. So that's really what we're looking for with the graphing polynomials sheet.